In this video, I will try to explain the background knowledge required for a reinforced concrete design class. So, uh, at the beginning, you should know the advantage and disadvantage of a reinforced concrete. The main advantage of reinforced concrete is like it is cheap, it can be made to any shape, versatile, and low maintenance cost. And something is like it has a good amount of compression strength. These are some good or common advantages. There are some others, you can read the book. Other topic is like disadvantage. The main disadvantage of concrete is that it has very low tensile strength, uh, and it is very heavy, so we cannot use it in the tall buildings. But as it is heavy, it is good for foundation also. Okay, so these are the main advantage and disadvantage of reinforced concrete. You can read books for to learn more, and then some knowledge you may need to study reinforced concrete design. So if I scroll the book, so advantage, disadvantage, then the compression strength. So something is like compression strength. I know that you studies plain concrete in your lower division classes. You took a concrete cylinder and applied some load, and you failed it, and you got a stress strain curve similar to this. So this strength is called A prime C. A prime C. That is the compression strength. Compression strength of the concrete cylinder, and we need to use it in our reinforced concrete design. So again, this strength is unconfined compression strength. Unconfined compression strength. But sometimes we call it compression strength. Even sometimes we call it concrete strength. So if I say A4 KSI concrete, so if I say A4 KSI concrete, it means the compression strength of this concrete is 4 KSI. So hopefully you revised your memory about this strength. So by strength means the unconfined compression strength of concrete cylinder. Okay, then something else we need to know. So this is stress, this is strain. Maybe my diagram is not good. Let me draw again. So I drew a stress strain diagram of three concrete sample. One is lower strength, little higher, then highest strength. Now something to observe here. Whatever the strength of the concrete is, the ultimate stress occurs almost at the same point, at the same line, and it happens at 0.002. When the strain in the axial strain in the concrete is about 0.002, at that time we get the peak or ultimate strength of the concrete. So you should memorize this number, because in FE exam this may be a good question. Something else, where the failure occurs. So failure here. So failure is occurring somewhere here, and this value is 0.003 to 0.005. So in this range of strain, failure occurs. So we consider this is our failure strain of concrete. So if in your FE exam, if the question is what is the failure strain of concrete, we use 0.003 to be safe. In fact, in our design, we will use this value 0.003. So memorize these two numbers. The peak or ultimate strength occurs at 0.002 and the failure occurs at 0.003, although it varies. So you learn two things from here. Another one, you can see here. Now the initial slope is called modulus of elasticity. That means the slope here is called modulus of elasticity. If I write here, it is EC. C means concrete, modulus of elasticity. You heard this term many times. Something to observe here. If my strength is less, my slope is less. Slope means modulus of elasticity. If my strength is higher, slope is higher. If my strength is higher, even my slope is higher. That means my modulus of elasticity is proportional to the strength, or the opposite. So it's proportional. If I write it down, yes. So it is proportional to the strength, but proportional to the strength. But the exact relationship between these two has been established by many testing, and that value is, if I write exact value, it is yes. By many testing, ACI developed this relationship. That means the modulus of elasticity increases with the increase in strength. Now what is this? This is the unit weight of concrete. Unit weight. So this will be in PSI. This will be in PCF, and this will be in PSI also. So the unit is, this will be in PSI, that means 4,000, 5,000, 3,000, and that will be unit weight of concrete. Typical unit weight of concrete is 145 to 155 PCA. But 145 is a better number because we use it in the most cases, and that is the most common concrete. So 145. Now this equation is in your FE exam, so better to understand this equation. This is unit weight of concrete, plain concrete, not the reinforced concrete. And if you use 145, you will get this equation as this. So EC is 57,000 F prime C. So you will get this equation if you use 145. So hopefully you understood this. Yes, as my strength is higher, modulus is higher. So that is something else from this curve, and we need this knowledge to study reinforced concrete. Anything else? Something else is that, what is the Poisson ratio of concrete? Actually, we do not need to use Poisson ratio, but just to know Poisson ratio varies from 0.1 to 0.21. Average number is 0.16. That is a good approximation. But mostly we do not need to use Poisson ratio in our design. Other knowledge we need: tensile strength of concrete. So you could take a cylindrical sample and apply diagonal load support here, and then there will be crack. There will be some crack somewhere. It may be here, somewhere here. So this is called splitting test. We can also do it by beam. Take a beam and apply load. So whatever it is, the tensile strength of concrete is roughly 8 to 15% of your compression strength. So 8 to 15%. If the average number say 10%. say 10%, average number. So if your concrete strength is 4,000, then tensile strength will be 10%, 400 kSI, so very less. Even when we design reinforced concrete, we assume that concrete has no tension, no tensile strength. Concrete cannot take any tension. We assume that because 10% of this is very, very less. Okay, so hopefully you got tensile strength Poisson ratio. Next concept maybe we need is about the reinforcing steel. So steel, or some better to write reinforcing steel or reinforcing bar. So in short we call rebar. So yes, the technical term is reinforced bar or reinforcing bar, whatever. In short, we call rebar. So we should know something about rebar. Rebar is made up with steel. Why do we need rebar? You can see here. If this is a concrete section, if I apply load here, it will bend. If I bend, the section will be like this. There will be tension here and compression here. So compression in the up, tension in the bottom. So if I apply load, the tension here, but concrete cannot take any tension, then what will happen? It will crack. So we use some reinforcement here. So concrete will crack, no problem. It still will take my tension. So that is the concept of reinforced concrete. We will know better in our next chapter. So this is why we need to use rebar. Now, what are the types of rebar? Types means by size. Yeah? So number 3, number 4, these are the number 5, number 6, number 7, 8, 9, 10, 11, 14, 18. These are the common number of rebar we use. Number 3 means diameter 3/8 inch. So this dia 3/8 is. This dia 4/8 is. This dia 5/8 is. This dia 6/8 inch. Similarly 7, 8, 9. From 10, 11, 14, 18 we have different calculation, but very close to this, yes. Then you can calculate the cross-sectional area, of the reinforcement, pi d square over 4. Now you do not need to memorize the diameter or area, it is in the book. You can just go and pick, but better to know some at least, so that you can go to very close to it. So whatever the number, diameter is divided by 8 up to number 9. From 10, 11, 14, 18, different calculation, but very close. Okay, something else. 3 and 4, mainly we use for tie stirrup, binding the main reinforcement. 5, 6, 7, these are very good. This is very thin, very good for concrete slab. Because slab is typically 4 inch, 5 inch, 6 inch, 7 inch, this thick. So 5, 6, 7 works good for slab. 8, 9, 10 good for beam column. 11 becomes little thicker, so very difficult to bend. So we typically do not want to use 11, 18 or 14 because this is so thick. Even in 11 means this so thick and very difficult to bend, so very difficult to use. So 11, 14 and 18 typically we use for bridge type structure where we need heavy reinforcement. Otherwise we do not use 11, 14 and 18 in our normal use. So for beam and column, this beam and column 8, 9, 10 is a good number. Slab 5, 6, 7 good. 3, 4 mainly for tie. Now if we use number 9 say in bridge, is it a problem? No, but just common practice. Okay, something else actually. 4 KSI, 400,000 PSI concrete is most common. Whatever concrete we see around is 4,000 PSI concrete, and 60,000 PSI steel is most common. Now, what is 60,000 PSI steel? 60,000 PSI steel means the yield stress of the steel is 60,000. That means if I draw the stress strain curve of steel, typically this value is 60,000 PSI. That is the most common concrete, most common steel. So if the problem does not say anything about the properties or strength of concrete or steel, you know it. Anything else? So let me scroll the book. I do not think you don't need anything else. And something maybe the unit weight of plain concrete is 145. It is a good number. The unit weight of reinforced concrete is 150 pound per cubic feet. So this is something to memorize. Yes, if it is plain concrete, unit weight is 145 PCF, pound per cubic feet. If it is reinforced concrete, 150 pound per cubic feet. I think I covered most of the general knowledge you need to study reinforced concrete design class. So in the next video we will start learning how to design reinforced concrete section. Thank you.